Alright, number 12A. The Pennsylvania Railroad Diesel Electric Road Locomotive Operating Instruction for Locomotive Enginemen, Firemen, and Helpers, 1949. Scan OCR conversion with the Rob Schoenberg, 2002. No, this document has not been thoroughly proofread. The Pennsylvania Eastern Central Region, Western Region Diesel Electric Road Locomotives Operating Instruction for Qualifying Locomotive Crews. General Notice. The instruction contained herein have been compiled with the view of the establishing uniform method of the instruction examination rating of the diesel electric locomotive engineer, firemen, and helpers who will be required to pass examination on these instructions obtain not less than a minimum rating. HLN Nancaro, WW Patchfeld, JP Newell, approved by HT Cover. Alright, general notice, general description. Section 1, general all locomotives, arrangement, classification, diesel engine, electrical power system, compressed air system, air brake system, firefighting system, locomotive operation, indication result, abnormal conditions. Section 2, oil-fired steam generators, description, operation. Section 3, class EP3, locomotive, general data, diesel engine, electrical power system, compressed air system, operation. Section 4, class BP1, locomotive, general data, diesel engine, electrical power system, compressed air system, and operation. Section 5, AP3, locomotive, general data, diesel engine, electrical power system, compressed air system, operation. Section 6, BP3, locomotive, general data, diesel engine, electrical power system, compressed air system, operation. Section 7, Class FP3, locomotive, general data, diesel engine, electric power system, compressed air system operation. Section 8, EF4, locomotive, general data, diesel engine, electric power system, compressed air system operation. Section 9, Class FF3, locomotive, general data, diesel engine, electric power system, compressed air system operation. Section 10, Class AF4, locomotive, general data, diesel engine, electric power system, compressed air system operation. Section 11, Class BF4, locomotive, general data, engine, general data, diesel engine, electric power system, compressed air system operation. Alright, general description, section 4, number 12A, June 4th, 1949, general description. Restrictions set forth herein include the general section designated in section 1 containing the descriptive information operating the instruction applicable for the all class for the diesel electric road locomotive, the steam generator section design, as section 2 containing the descriptive information operating instruction for the steam generator on classes so equipped. The supplemental section of each of the diesel electric road locomotives indicated with the index provides additional description information operating instruction required for that class of locomotive. Enginemen, firemen, helpers will be furnished with a copy of the instruction diesel electrical road locomotive. They must be avail themselves on the facility provided in order to receive the instruction. Must continue to study out subjects as outlined in the instruction to become well informed. Must pass the required examination. Alright, diesel electric road locomotives operating instruction, section 1, arrangement and classification. Diesel electric locomotive, the locomotive propelled with electrical traction motor geared with the drive and axle, the power of which supplied by one or more electrical generators driven by one or more diesel engine locomotive located on the locomotive. When the diesel electric locomotive throttle is open with the main generator of the commonly automatically traction motor with electrical power flow with the motors to move the locomotive. As the throttle is open, wired with the diesel engine speed up to deliver more of the mechanical power to the main generator, thus more electric is power to the generator for the traction motor. When the throttle is wide open, the diesel engine runs at a maximum speed and the power output of the main generator regulates itself so that the traction motors are supplied with the required horsepower up to the maximum rating of the combination of speed and train load. Locomotive consists of one of the unit or two or more units operating with a multiple. When operating a multiple, several units are under the control of the one operating cab. Locomotive units with the operating cabs are designed as the A units. Those with operating cabs as B units. Control station is provided with the B units from the unit may be operated with independently from hostling. There may be two operating cabs with a complete locomotive with one each of end, so the locomotive may be operated with either direction without turning. Classification U for the diesel electric road locomotive, the designation class for locomotive 2, initiating letters followed by the number, the first letter designated with the manufacturer of the diesel engine, second letter for the service passenger of the freight, and the following number designated for the number of the comparable units making the incomplete locomotive. Thus, the road passenger locomotive, the EP3, with the 3 units of the Electrical Motor Division of General Motors Corp. BP1 stands for two semi-permanently connected with the Baldwin Locomotive Works. AP3, 3 units of American Locomotive Company. BP3 stands for 3 units of Baldwin Locomotive Works. F stands for their units of the Fairborn Morse Company. Similarly, the road freight locomotives are EF4 with the 4 units of the Electrical Motive Division of the General Motors. FF 3 units of the Fairbank Morse Company. EAF 4 units of the American Locomotive Company. BF 4 for the units of the Baldwin Locomotive Works. The nominal rating for all the various classes for the diesel electric road locomotives is 6,000 diesel engine horsepower. The EP3 with the BP3 passenger locomotive, they're made up of two A units and one B unit, each containing two 100,000 horsepower diesel engine with two 3-axle trucks under each of the unit. The BP1 locomotive consists of two semi-permanently connected with the A unit for each of the containing with the two 15 horsepower diesel engines hanging articulated with the mainframe with 8 driving axles, two 4-wheel guiding trucks. The AP3 and the FP3 locomotives consist of two A units and one B unit, and each of the unit containing 2,000 horsepower diesel engine with the two 3-axle trucks under each of the unit. The E4A4 locomotives are made up of two A units and two B units, each containing the 15 horsepower or 1,500 horsepower diesel engine with the two axle trucks under each unit. The FF3 locomotives are made up of two A units and one B unit, each containing the 2,000 horsepower diesel engine with two 3-axle trucks under each of the unit. The front end of the locomotive unit is designated by the letter F painted on each side, but the A unit is the operating cab is the front end. The right and left side of the locomotive unit is designated with the right and left hands when the locomotive of the unit facing the front end. The hoister operating the position of the B units is on the right side of the unit. Truck, axles, traction motor, diesel engine from the unit, the number consecutively being the number 1 and front end of the unit. Diesel engine. Being the name of the inventor of the Dr. Rudolf Diesel, the diesel is all internal combustion, ignition, fuel, oil burning engine. Internal combustion engine only one that derives the power for the burning of the charging the full inside of the cylinder. Fuel is then sprayed into the cylinder with the diesel engine thoroughly with mechanical pressure operated fuel injectors. Compression ignition means for the charging of the fuel with igniting with the coming in contact with the highly compressed, hence with the highly heated air of the combustion chamber of the cylinder. This is main distinguishing between diesel and other internal combustion engine, where the ignition is achieved by the use of the electrical spark with a hot spot. Diesel engines and internal combustion engines in general are divided in two main groups: the 2-cycle and the 4-cycle. The engines of the 2 and 4 designate the number of the strokes a piston necessary to complete a cycle with the operation of the cylinder. The cylinder cycle is being the intake of the compression power of the exhaust events. But not both non-supercharged, normally aspirated supercharged engines are in use today. Non-supercharged engines intake air induced with the cylinders and prevailing atmospheric pressure, and supercharged engine intake is air forced into the cylinders by the intake of the air pump supercharger. The supercharger used in the internal combustion engine is the mechanical device supplying the engine with a greater weight with the volume intake that would normally be induced by prevailing atmospheric pressure. It may be either mechanically driven or powered by the exhaust gas driven turbine and built integral with the supercharger, later augmented with being known as the turbo supercharger. The increased amount of intake are induced with the supercharging increase the power that can be obtained with the given size of the cylinder, causing the more complete combustion of the fuel chamber with a proportionate increase of the power output. Diesel engine governor. The governor is the speed-sensitive device primarily used to control the limit of the speed of the engine with the use of the diesel engine. Locomotive service measure with the rotative speed of the engine through direct mechanical connection with the engine through an electrical connection with the tachometer generator driven by the engine is function with the control speed of the engine at its settling, determined most by the position of the throttle lever the Engineman control stands. The Engineman throttle lever is connected into the governor in one of several ways as follows: by direct mechanical linkage with the governor control shaft, by electrical connection with the pneumatic hydraulic mechanical mechanism, which may either be mechanically connected with the governor control shaft built integral with the governor. 3. By straight pneumatic connection to the air actuator, which was mechanically linked with the governor control shaft. The governor in all cases is mechanically connected with the fuel injection system of the engine so that it vary an amount of the fuel injected with the cylinders. Under certain conditions, such as a sudden loss of electrical load caused by the wheel slippage, ground relay tripping, the governor may fail to limit the engine to its maximum speed. All diesel engines and the locomotive service are provided with the overspeed with the stop mechanism will automatically shut down the engine down should the speed approximately 10% above the maximum governor speed. The overspeed stop device may be functioned through an electrical connection to the governor through the direct mechanical connection to the engine. The diesel engine cooling system. The water and the air circulating with the cooling system is designed to carry the wave that disperses the excess of the heat generated inside the engine. System consists of expansion storage water tank of the water circulating pump, usually mounted on or driven by the engine circulating passages, jackets in the engine with the radiator through the air withdrawn with a mechanically motor drawn fan for the motor driven fans flow of the air being through further control by the shutters and the necessary pipe gauges, valve fittings, and venting of the drain connectors. Diesel engine lubricating oil system. Alright, the lubricating oil circulating system is designed to supply the lubricating oil under the pressure of various working parts of the engine and associated equipment. The elements of the pressure lubrication system are stored space of the fuel oil positive displacement, suction pressure, circulating mount, pump mounted on the driven by the engine strainer and the filter units and head passage and the engine of the oil cooler with the necessary piping valves, gauge, filling, and draining connections. Diesel engine fuel oil system. The system is designed to supply the fuel oil under the pressure of the individual engine cylinders. The system contains a fuel supply tank with the fuel transfer pump, with electrical driven, the fuel injection pump, the injectors, the filter unit with the necessary piping, the valves, gauges, filling, venting, and the drain connection. The fuel system on each of the unit of the locomotive is equipped with the emergency fuel cutoff located with the suction line between the fuel supply pump and fuel transfer pump. The valve is tripped into the cable connection to the pump, the horn, and other various locations of the unit with the trip that may be reset manually to the open position to reset the emergency fuel cutoff, the raise for the valve stem, slip crutch under the stem to hold the valve open. Electrical power system. Or electrical power system. Diesel for the diesel electrical locomotive, each for the main direct current with the direct connected with the crankshaft of the engine, electrical power with the generator, the transmitter, the electrical cable driven, the traction motor, which are geared with the driven axle, the cable is provided with the means to carry out the current flow with the generator, with the motors for its return of this generator. The path of this flow is known as the circuit of the diesel electric locomotive is completed with the return through the locomotive frame in the ground, but thus known as the underground circuit of the ground should occur to the failed insulation. Failure of insulation in the cable's electrical apparatus for the connector with the circuit. Serious damage may result to protect against such damage. The ground relay will give an alarm indication removes the electrical power for the circuit of the bolt of the connection of the power circuit from the main generator. But the traction motor is made through power switches operated with the air and electrically. Such power switches are known as contactors. In starting the train, high pulling power, the tractive effort is required for the electrical motor mechanical force proportional to the current amperage. Starting with the high current required for the standstill, low voltage sufficient to produce the higher current in the motor so that the low generator voltage, low generator speed are used. As the locomotive speeds, consequently, the motor speed increases with the high voltage necessary to produce the required current, but the motor is prescribed to the counter voltage generated internally with the motors. Consequently, the generator of the voltage must be increased with the increasing in the speed. If the higher current is to be maintained, the speed of the diesel engine's main generator is controlled with the throttle lever of the governor, and the diesel engine is sped up with the voltage of the generator increases the maximum about 1,000 volts. If the current amperage drops rapidly after the initial acceleration of the train for any throttle position, the full throttle current continues to drop as long as the train is accelerating, increasing speed. For the given engine speed, the main generator is regulated with the producer substantially contained with the maximum power output under the condition of the constant power output, the product of the traffic effort, the time speed with the constant for all the speeds. In other words, the speed increases the pulling power, but the decreases accordingly. In the same way, the product of the generator voltage to amperes and constant for all the amperes of the train speed increase, the current decrease, the voltage must increase accordingly. After the main generator has reached the maximum rated voltage, however, the speed of the train continues to increase, the current will continue to fall off. Thus, the power output, which is the product of the current times the voltage, will decrease. Under these conditions, the full output of the diesel engine is no longer being utilized. Full output can, however, be again put into the use by two different methods. One method is the traction motor field shunting, and the other is changing the connection for the traction motor to the main generator of the series of parallel. The action making these changes include transition. Transition is accomplished automatically on some locomotives. It can be controlled limited manually on other locomotives by the transition lever, which is located on the control stand along with the throttle lever and the reverse lever. As starting at the lower speed with the traction motor fed by one of the main generator being connected within the series parallel with the current flow through the one motor for the pair of the motors, then through the other motor with the pair motor. Within this way, the current voltage is generally internal with the traction motors, or also series altogether with the double main generator voltage required for the cause of the current flow, as would be required with the one motor connected with the generator. If, however, the transition parallel connection is made with a higher speed, is done on the same class of locomotive, that is, the motor is reconnected with the generator. The current divides equally, flows through all motors in parallel. The current voltage generated in the motors are not added together. The current will flow for each of the motor as though it alone was connected with the generator. Under this condition, the same main generator voltage will produce twice the current flow per traction motor as the series of parallel connections to the same maximum generator voltage will produce twice the motor current. With the representative of the track effort, pulling power, the fuel utilization, engine output can be attained with the higher and speed of the transition of the parallel connection motors. The second of the form of the transition will obtain all the locomotives known as the traction motor field shunting. The traction motor with the series type of the same current flows through the motor armature with the winding of the rotating portion, the motor field with the winding of the stationary portion in series. The speed of the traction motor with the locomotive locomotive can be increased by bypassing some of the current by the motor field winding through resistance will permit the greater current of the flow with the motor armature winding with reducing the backflow voltage generated by the motor. Thus, similarly to the transition parallel connection, it will permit the same maximum main generator voltage to produce more current through the traction motor. Permanent fuel or use of the engine output field shutting can be accomplished when the number of the steps is used on some of the locomotives. It can also be done with a series and series parallel and full parallel operation is also used. Higher speeds of given motor connection. Reversing. The direction in which the DC motor rotates determines the relative direction in which the current flows through the armature winding of the field winding. If the current is reversed through the one or other motor while the turning in the opposite direction, if however both are reversed, there will be no change in the direction of the rotation of the motor, although either can be done. The traction motor is usually reversed by reversing the field windings and connection. The reverse switches will accomplish this through the reverse lever on the control stand. The motors must not, and under any conditions, be reversed while in motion. Load control. Control power output of the main generator so the diesel engine will not slow down below the speed determined by the throttle lever position and known as the load control is power that the generator is required given throttle position and speed governor on the diesel engine emits more fuel until the predetermined fuel limit of the engine is reached for the power requirement and increase beyond the point of the diesel engine will be unable to maintain its speed. However, at this point the load control will automatically reduce the power output of the generator, thus permitting the diesel engine to run for the normal speed they accomplish by reducing the current known as the exciting current through the main field winding of the generator. The turn reduces the voltage generated by the main generator, hence the current of the power to output. Dynamic braking is the means of retarding the train which can be used with the locomotive propelled with the electrical motor of the traction motor that connected with it as a generator operated with the engine energy of the moving train. A diesel electric locomotive having the dynamic braking electrical energy produced dissipated as the heat of the bank of the resistance called grit. Dynamic braking is effective with the course only of the wheels of the locomotive which have the traction motor in the same care should be used applying the dynamic braking using the independent brake on the using the independent brake of the on the locomotive. Independent air brake and the dynamic brake must not be both used at the same time. The driving wheels may be slide. Dynamic braking accomplished by the actuating switch with the connecting the traction motor armature windings with the grid and by the applying of the current with the traction motor field windings from the main generator. The greater the current applied with the field windings, the greater the braking current generated by the traction motor. As the locomotive slow down with the slower speed of the traction motor reduces the amount of the power generated. Consequently, the braking effort of the dynamic brake decreases, so that it is not practical to stop the train with a dynamic brake. In order to prevent overloading with the traction motor, the dynamic brake must be limited to the amount of current which can be carried safely by the motors. If not possible to hold the train in the desired speed, means of the dynamic braking, the automatic air brake may be applied in conjunction with the dynamic braking, keeping off the locomotive brakes on class with having the dynamic brake, which is the transition lever. It uses the amount of the dynamic braking power is controlled by the position braking range of the transition lever, and which no transition lever is provided with the reverse lever of the dynamic braking position. The brake power is controlled by the throttle lever. Control system. The power circuit of the diesel engine main generator circuit electrically independent each of the unit of the locomotive with the same unit with more than one diesel engine main generator located on one unit. Since however they must be all controlled with the one location on the locomotive, they are all connected by the multiple unit control system. System permits the control engine of the engine speed with all engines by throttle level. The control stand forward reverse operation of the locomotive by the reverse lever on the control stand, stopping only the diesel engine on the locomotive if required for the operating power circuit of the transition were manually connected or manually controlled transition lever on the control stand with the operating control dynamic braking on all units where the locomotives are equipped. On locomotives equipped with the steam heat generators, a panel located on the fireman's position it contains the control shutting of the steam line with the valve for all steam generators, also operating with the steam generator separated blow down valves. The control system energized with a normally 64-volt battery circuit consisting of a 32-cell battery with each of the unit charged with an auxiliary generator with the control switch to the Engineman position. The close the established power of the control stand is the location of some of the locomotive fuel pumps and generator field with the switch is used because it should also be closed for the Engineman location before the control is established operating end of the locomotive. All locomotives have the Engineman's position loaded indicated with the ammeters giving the amount of electrical current passing through the motors in order to prevent overheating and damage to electrical equipment that must be used with the guide in the operating of the throttle lever, the transition lever during the running during the braking of the dynamic is used. Auxiliary power system. All diesel engine locomotives equipped with the auxiliary generator driven with the diesel engine. The generator should be used with a storage battery to supply the low voltage power to the auxiliary control apparatus of the diesel engine running. On some class, the locomotive with the traction motor blower, the controlling of the traction motor with the motor driven by the power of the main generator, separated blower generators. On other class of the traction motor blowers are driven mechanically connected to the diesel engine crankshaft. On some locomotives, alternating running current with the alternator driven by the diesel engine, supply power with the traction motor blowers, also engine with the radiator cooling the fan motors. On other classes of locomotive, the engine radiator, cooling fan, or motor operated with the power of the from the main generator, fan blower, and or mechanically driven the diesel engine. The traction motor will be overheated, seriously damaged. The locomotive continued under load with blowers inoperative. In addition, with the fans, the engine radiator cooling and the blower, the traction motor cooling fans that are equipped with the cooling of the grids used to dissipate the electrical energy, with dynamic braking used for the lands are operated with the banking connection across the portion of the brake grids, thus using some of the power generated the brake to operate the fans, but the arrangement of the fans operating only with the dynamic braking and the operation fan speed depends upon the braking current. On all diesel locomotives, the fuel transfer pump that each of the diesel engine motor driven the battery auxiliary generator circuits where the fuel pressure always available to the diesel engine is to be stored with the prompt shut-off that can be obtained with the desired the current supply of the site with the main generator field winding, taking the auxiliary generator battery circuit on the some locomotives from separate exciter generator driven by the diesel engine. Lighting in the battery system. All locomotive units have 32 cells, nominally 64-volt storage battery. One of the principal functions of the battery is to crank the diesel engine. Each of the engines of locomotives is started individually with starting controls located on a panel nearby the engine. After the engine starts, the controller may be stopped from the engine man location. Starting up, the must, however, be done with the individual engine. The battery charged with the auxiliary generators on the one unit of the charging voltage controlled with the voltage regulator to maintain the constant voltage, approximately 74 volts. When the engine is not running at the speed too low to give the sufficient auxiliary generator voltage to charge the battery with reverse current relay only open for the connection to the battery to prevent the battery discharging the auxiliary generator. The battery is used for the lights of the operating cab of the engine room that provides the power for the control indication circuit for the locomotive. The locomotive is equipped with the motor generator set on the A units will provide with a well-regulated supply of 32 volts for the operating of the train phone equipment of the cab signals. This is set operated with the battery power with 32-volt output with the generators used with the operated with the headlight of the locomotive. The battery circuits generally have the fuse to protect against the overload short circuits. In some cases, the thermal overload circuits and breakers are used in places of fuse. They may be reset but after tripping and opening. And the main battery switching is provided with a disconnect of the battery from the circuit and the unit is shut down. Compressed air system. Each diesel engine is connected with a two-stage air compressor which takes the air from the atmosphere and delivers it under the pressure of the main reserve when the air is stored and cooled, in which the moisture contained with the air condensed in the water from where they readily drain before the engine for the various operations of the air system. Air from the main reserve is piped with the air brake system, the air control system, the other air operated with the use devices used throughout the locomotive. The main reserve is connected by the units of flexible hose connection so that they combine air capacity with the several air compressors as well as combine volumes of the several main reserves of air available throughout the entire locomotive. Air compressors. Several types and sizes of the air compressors used with the size depending on the rotative size of speed of the diesel engine and the number of each of the unit. The 2 and 3 cylinder compressors are used. 2-cylinder compressors have only one low pressure, one high pressure. The 3-cylinder compressors have 2 low pressure cylinders, one high pressure cylinder. In either case, the rotating radiator type of the intercooler is located between the low and high pressure cylinders cooling the air. The self-contained lubricating oil system lubricates the compressor from the supplying with the oil carried within the air compressor crankcase. Air compressor governor. The main reserve pressure is controlled by the governor system with the loading and unloading control of the type of the system is necessity in the continuous running of the air compressor for the all time of the diesel engine. The running the governors are electrically controlled, synchronized between the several locomotive units that maintain the main reserve pressure between 125 to 140 pound safety valves provided to prevent excessive main reserve of the pressure of the governor and control the defect of the cutout. Air control system. The air pressure used for the operating electrical contact reversers and controlling the rotative speed of the diesel engine on some of the classes supplied with the main reserve throughout the reducing valve control reservoir on each of the unit. The control air pressure to maintain from 70 to 80 pounds pressure reducing the valves on some classes of locomotives. Control air pressure is used for operating with the cooling system of the radiator shutters. Use the main reserve pressure. The main reserve pressure is used for the operation of the cooling system, radiator, shutter fans on same class, locomotive bell horns, wind wipers, sanders, are operated at the air main reserve pressure. On units equipped with the steam generator, the atomization supply with the main reserve throughout the separate reducing valve sets at 70 pounds. The operating communication signal whistle cap, the signal warning whistle supplied with the main reserve throughout the reducing valve is set 45 pounds. The air system includes the various filters to clean the air and number the cocks valves and shutting off local air supply when the necessary to drain system when required. The air brake system. The 24RL locomotive brake equipment is used only on the all class for the low diesel electric road locomotives. The only difference between the classes is between the passenger class locomotive equipped with electro-pneumatic operation as well as pneumatic operation, while the freight class locomotives are equipped with pneumatic operation only. The equipment includes on each A unit the automatic brake valve, the DSH24H passenger, and the DSH24H for the freight, with the means of which the brake system of the locomotive of the train is charged with the control. Independent brake valve, the S40D for the passenger, and S40F for the freight, with the means designed with the locomotive. The brakes may be controlled with the independently trained the train brakes. Combined equalization, reducing, limiting reservoir for the first service of reduction with the brake pipe pressure. Rotary valve, the type K2 and K2A, for the cutting of the independent brake valve on all A units except for the one in which the locomotive is being operated, selecting the emergency brake cylinder pressure development required for the type of the length of the train handled. The K2 rotary valve with a 3-position passenger lap in the freight should be in the lap position on all and A units except for the cab with which the locomotive is being operated should be set in passenger position for non-controlled emergency brake cylinder with the development and freight for position controlled and emergency brake cylinder development with the K2 rotary valve with the control emergency pipe with the connection between the units. K2A rotary valve that has 4-position passenger lap, freight lap, and the freight. There should be the passenger lap with the freight lap on all A units except in the cab with which the locomotive is operated, which shall be in the passenger freight position with the passenger lap, non-controlled development, emergency brake with the cylinders obtained within the freight and lap controlled development, emergency brake cylinders pressure is obtained. When the K2 valve with the freight position controlled the emergency and the entire locomotive with nullified placement with the independent brake valve with the application to the position during the emergency application between the K2A valve with the freight position only with the unit when the locomotive is being operated with can be controlled emergency application nullified. Electro-pneumatic master control operators under the control of the automatic brake valve during the electro-pneumatic application of the brake engine with the proper magnet valve with the 21B magnet valve. The 21B magnet valve contains the application magnet valve with the release of the magnet valve with the cutoff valve. The magnet valve controls straight air pressure under the control of the master control. The D4 control valve, the operative with the control application relief of the locomotive brakes, the dead engine cockpit with the control valve with the normally live position provided that the charge of the main reserve of the brake pipe will be placed in the dead position. Relay valves control the flow of the air into the brake cylinder with the apply the release of the brakes that combine with displacement, auxiliary, and emergency reservoir. With the control of the valve with the synchronized locomotive brake cylinder, the pressure development and one train during the service application to provide high brake cylinder pressure during the emergency applications. The H5A relay valve causes automatic sanding during the emergency application. The various valves, the cocks, piping the means of the flow of the air can be cut off when required. The brake equipment on the B unit includes the control valve with the combined with the displacement auxiliary emergency with the relay valve that controls the emergency cock, and the control valve selected with the type of the brake cylinder pressure developing according with the position control of the emergency cock with 3-position, P for passenger, non-controlled, L for lap, and the F for the freight for the control of the emergency. B units equipped with a hostile brake valve that means for the unit brakes over the unit of control with the necessary to move the unit alone with reducing the valve adjustment of the brake pipe pressure for the furnish the air to the brake pipe with the release the automatic brake application. The cutout cocks under the one holster brake valve, the other, and reducing valve pipe connection to the brake pipe must be opened to permit the control of the holster brake valve. Alright, 10-minute overspeed safety control feature including the reduce the power of the diesel engine applied with the brakes and serve with the engine being in a capacitated or maximum permissible speed be exceeded. The equipment comprising with the safety control feature include the double heading cockpit, which cuts out the same safety control feature for the trailing cabs, which is closed in the number 2 position. The service application of the portion of the automatic brake valve, which for the actuated initiate of the service application of the brakes, the safety control check of the operator with the depressing automatic brake valve handle to suppress the dead man application. A diaphragm foot valve with a pedal which when held down, suppresses the dead man application. A warning whistle, which will sound with a limited time before the safety control application occurs, should be both automatic brake valve handle and diaphragm foot valve pedal be released with a dead press of the position, little or no brake cylinder pressure present. The H24 relay air valve that operates for the suppressed safety control application about 30 pounds of the brake cylinder pressure exists. The HZ4 relay air valve has provision for in some classes includes the application ensuring the feature overspeed application feature overspeed suppression feature. An overspeed magnet valve, which which must be electrically energized to suppress safety control application when the brakes are released. A whistle is provided will blow whenever the magnet valve is de-energized. Safety control cutout Safety control cock, normally sealed within an open position located with the surface application portion of the brake valve closing the cutout cock for the safety control features. Cutout cock, normally sealed with the open position located in the pipe between the diaphragm foot valve with the H24 relay air valve, the closing of the cutout cock for the dead man feature. The cutout cock normally achieved in the open position located with the pipe and the overspeed magnet valve with the brake valve, the closing the cutout cock of the overspeed safety control. Emergency application of the brakes of any cause of the safety control application operates pneumatically controlled safety, for which to remove the power of the traction motor requires the throttle lever to be placed in the idle position before the power can be reapplied. The firefighting system. The system is arrangement and equipment with detecting and extinguishing any fires likely to occur with the locomotive. The fire detecting system consists of the electrical thermostat mounted in strategic points each of the locomotive. The control and active of the parallel relay warning device in each of the operating cab. Excess temperature condition will be caused with one or more of the thermostats enclosed with the contact energizing of the relays which operates the warning device. The fire extinguisher consists of the two set of the 250-pound capacity carbon dioxide cylinders installed at each of the engine room, two hose stations, and each side of each of the locomotive unit, one near the front, one near the rear of each of the side, two remote control pull boxes mounted near each of the hose station connected by the flexible steel cables to the control handle heads of the cylinder, one box mounted inside of the unit near the hose racks, and one outside within the reach of the ground. The two set of cylinders, each locomotive unit with the cross connected with the piping, and so that one acts as the reserve for the other. The cylinders are connected to the hose station piping, which the installed just ahead of each of the hose normally closed with a quick action direction valve, which must be opened before the respective hose can be used on a fire. Each hose station is equipped with a 50-foot flexible hose complete with a discharge horn squeezed with the grip to discharge valve. The pull boxes are so connected that the two sets of cylinders, each of the locomotive unit, both set and can be operated with either side of the unit. The system and each of the locomotive unit are equipped with means of a flexible connection so that sole carbon dioxide supply each of the unit can be used with a reverse supply for each other. Operating instruction for the carbon dioxide or the CO2 system. Open pull box, pull handle hard with this release the carbon dioxide with the both cylinders in one set. Throw the lever with the clicking action directing valve with the piping adjacent to the hose rack. This fills the hose with carbon dioxide. Run the discharge hose to the fire. Squeeze the valve lever to the discharge horn to release the carbon dioxide. Direct the discharge at the base of the flame. Additional carbon dioxide is required to operating pull box for other side of the cylinders and units. To obtain the carbon dioxide with the cylinder joining the unit, the throw lever the direction valve with above the door end of the joint. The discharge of the cylinder is required with the joining the following the instructions 1 and 2 above. That any of the fire has been extinguished, required turn all the direction valves to closed position. Bleed the hose line and the gas squeeze with the valve lever of the discharge horn. Carbon dioxide is a non-conductor of electricity, which makes it desirable to combating electrical fires and non-poisonous. However, it does not carry oxygen in any form of sustaining human life. Whenever any of the questions about the carbon dioxide in confined space, whether fire has been extinguished, care should be exercised before entering the space so that it is completely ventilated. Anyone overcoming the carbon dioxide should be moved quickly in the fresh and artificial respiration applied. The carbon dioxide system each of the locomotive unit was supplemented with the 230-pound Douglas hand extinguishers primarily for the fires outside, not to be used inside unless the fire is not extinguished by the carbon dioxide system. Our procedures in case of a fire. If the fire alarm is received, the lighter bell or bowl to stop all the diesel engine operating emergency engine. To stop the engine position, stop all the fuel pumps operating by opening the fuel pump push button switch and circuit breaker to the engine man's position on the class that is equipped. B. Investigate. If the fire is discovered, to stop the engine fuel pump. If it is not already done, make the full service application of the brakes. If not already done, pull the emergency full cut off of the units involved. C. If the fire equipment is followed, run the gear beneath the cab. Use the Douglas hand extinguisher. Traction motors use the carbon dioxide CO2 hose system. Locomotive interior, they use the carbon dioxide CO2 hose system. In the event of the extinguisher failed with the carbon because of the exhausted before the fire extinguisher, use any of the extinguisher at any location. No, fire hazard. When continued operation of the diesel engine steam generators, the apparatus would constitute the fire hazard due to the fuel oil leaks out of the reason the apparatus must be shut down until the hazard condition is corrected. Locomotive operation inspection. When taking charge of the locomotive through, the inspection should be made with the entire locomotive to determine if any one of the working on and about locomotive, if any of the equipment is missing under the repairs, any tools or equipment that has been left there near the operating parts, If the locomotive consists of several units, see that all the electrical jumpers properly connected between the units. See all the air hoses connected between the units and cocks open. On passenger locomotives, see that the heat continues connects between the units the proper made with the valves opening. On each of the units, you check the fuel oil level, lubricating oil level, cooling water level, steam generator water supply tank. Set the drains enclosed for the air reserve cooling water system lubrication oil system. See that all side of the connection steam, fuel, water, electrical are disconnected clear of the locomotive. Preparation for service. In preparing the locomotive for the service, see the battery switches that close on each of the unit to check for the several lights for the circuit to see that they operate properly. At the engine position for the cap of the control unit, note that the throttle lever in the idle position, reverse lever in the off position, transition lever where in the off position, close for the control switch, the fuel pump switch when provided with the leaving generator field switch open. Class is so equipped so that the automatic brake valve handle in the running position, double head and cock open. See the independent brake valve handle in the fuel application position, rotary valve, the position, passenger position. Only are the units close to the switch. It is on distribution panel. Note of all the fuses are in place for the class is so equipped to close that all circuit breakers on the contractor compartment can panel. In Engineman position, engine control, cab trailing unit with note the throttle with the leverage in idle position, reverse lever in the off position, handle to remove the transition lever when used in the off position, so the automatic brake valve handle to remove the running position, double head and cock closed. See that the independent brake valve handle to remove the release in the running position, rotary valve in the passenger lap with the lap position. See the control switch open with the unclosed and equipped, so that the fuel pump generator field switches are open. Start the diesel engine from the engine for the control panel. Note that the proper lubricating oil pressure obtained, after which isolation switches should be closed and then runner on position. Alright, charge the check for the charge indicator. See the auxiliary generators are functionally properly with the batteries receiving the charge. See that all the engine on the line with the operating throttle with the reverse lever opposition, generator field switch open with the on locomotives equipped. To check each of the diesel engines to see the running speed of the corresponding with the throttle position. Steam generator provided are to be operated with the start of the steam generator for the units required. Note that a steam generator should not be operated for the on a unit more than several minutes unless each one of the auxiliary during the units is in service. When required, a departure of the tab of the test for the cab signal must be made, but the required for the departure test for the train phone must be made. When proper main reserve pressure obtained with the test, air brakes to see that the function properly with both ends in all position of the brake valve, the safety control equipment, and cutting on operative. Both before attempting to move the locomotive, see that the shocks and the chains are removed from under the wheels and the handbrakes are fully released in all the units. Engine cooling water temperature should be at least 125 degrees before operating under load. Cab signal circuits are supplied with the 32-volt power for the motor generator set. The set operated with the battery auxiliary generator circuit set through a 50-ampere thermal overload circuit breaker. The 32-volt output for the motor generator set is normal supply of the cab signal equipment, teller, train phone, and headlight. Changing ends. The operating end, the following procedure should be followed. See that the throttle lever is in idle position. Use the transition lever to use the off position. Remove the reverse lever to the off position. Make a full surface brake pipe reduction, at least 20 pounds. Close the double heading cock to remove the automatic brake valve handle. And the run position, place the rotary valve in the passenger or lap position. Remove the independent brake valve handle to the release and running position. Open the generator field switch, which when provided with open the control switch. Open the fuel pump switch provided with except on some class that the fuel pump switch must be left closed until the fuel pump switch on the other end is closed, after which it must be opened and proceed to the end of the being cut and close control switch. Close the fuel pump switch when provided. Place the reverse lever and place the lever on position off position. See the throttle lever in the idle position. See the transition lever when used in the off position. Put the independent brake valve handle in place. Move the fuel application position. Place the rotary valve in the air passenger position. Put the automatic brake valve handle in the place and leave within the running position. Open the double heading cock slowly to move the locomotive. Close the generator field switch when provided with the reverse lever in the forward reverse position. Transition lever provided number 1 position on the class. The transition lever provided with the automatic transition being used. The transition lever should be placed in the position specified by the particular class of the locomotive. After any of the shifting movements must be completed with on class for the locomotive manual transition being used. The movement of the transition lever should be made to indicate the locating indicating ammeter. Hold either the dead man pedal or automatic brake valve handle in the depressed position to prevent dead man operation. Release all the brakes. Open the throttle into the first notch. Note that the amperage is indicated with the load ammeter. Open the throttle gradually, passing each of the position long enough to permit the load and ammeter pointed at the cell standing reading until the locomotive starts to full. Further movement of the throttle lever depends on the proper handle of the train due to the slag action permissible speed. During the standing of the acceleration, load and ammeter point may be moved in the red portion of the scale without any restriction desired in order to permit the high tractive effort. Road operation. During the operation over the road, the low diameter point must be kept in the white portion of the scale, except for under the conditions prescribed under each of the classes. And brake the train. When the braking of the train slowed down at the stop, the brake may be applied with using the power half with the throttle lever. Should be placed in the lower notch while braking. While braking or powering must be shut off before the stop is completed. When crossing the railroads of grade, the throttle lever must be placed in the low notch to prevent arcing between the traction motor brush with the communicator. Locomotive must not be operated through the water deep enough for the touch the traction motor when passing through the water to the level of the railhead. Reduce speed of the not over 55 miles an hour. The reverse lever must not be moved to the position operating with the operation direction while the locomotive is in motion. When leaving the locomotive cab, the reserve lever must be removed in the opposition. Care must be exercised to prevent operating the emergency engine stop, except for the emergency. The emergency engine stop is operated with the pushing of the stop button on some classes, while on the other classes, the throttle lever incorporates the top position, which is made available. Positioning unlatching bottom of the end of the throttle lever when the emergency engine stops is operated. All diesel engine locomotives will stop. On class of locomotives incorporating dynamic braking, the train speed may be controlled by using the following manner. When the throttle lever in idle position, move with the transition lever. The class is equipped with the off position. Move with the reverse lever back to the lever to braking position with the provided with the pause until the train slack is adjusted. Move the transition lever to the class with equipped with the B position. Low diameter will indicate the amount of the braking. The current will be generated with the traction motor. If the current is below the maximum speed, further braking effort is required. Move the transition lever, the throttle lever on the class with the throttle lever to use the progress of the braking zone. As speed decreases the traction motor braking current will decrease. The lever may be moved forward at the braking zone. May be careful not to exceed the maximum permissible current. The dynamic braking warning light will limit the maximum permissible current exceeding any unit. If the train cannot be properly controlled by using the dynamic brake alone, the automatic air brake may be applied with the supplement to keeping the locomotives released and to avoid the wheel slide. Diesel electric locomotives equipped with wheel slip relays operated with reduced power output. The diesel engine with the wheel slipping and curved light indicating light will be operating the buzzer to both. When wheeling, slipping, stop with the relays, the reset automatically slipping condition minor with no action needed to be taken. However, the slipping continues, the all lever position should be reduced and sand should be applied with an if necessary. The use of the sand should be restricted to absolute necessity. Do not apply sand while the wheels are slipping. If necessary, to pump the air faster with the locomotive standing at the drifting in place of the reverse lever on the off position, open the generator field switch on the locomotive so equipped, move throttle lever to the position to obtain the pumping rate required. Alright, isolating a diesel engine. Multiple unit control of several diesel engine locomotives being completely through an isolation switch located in the engine control panel. Each of the diesel engine permits one or more of the engines to remove the multiple unit control. This is known as the isolating engine. This is done operating the isolation switch of the isolation position. The engine is removed from the multiple control, operates at idle speed. The action of the returning of the engine operation under the multiple unit control is known as the engine on the line, accomplished by the moving isolation switch of the run position. If the engine is to be stopped, should be first isolated, then stop the switch, and then bottom when provided that should be operated with the isolation switch turned off the position on locomotive so equipped the engine has been stopped with the fuel pump switch should be placed in the opposition. Ground relay operation. The ground relay operators must be reset manually. Before resetting the ground relay on the diesel engine must be isolated. If after several repeated operations the relay fails to remain reset, the diesel engine should be left off of the line. If necessary, in order to handle the train to operate with the diesel engine involved with the traction motor cutout switch provided with the some class to cut out the traction motor, and cutting out the traction motor eliminates the ground condition. The diesel engine may be restored to serve the operating of the remaining traction motor. If, however, the condition cannot be overcome in this manner, manually ground relay cutout switch is provided with which prevents the further operation of the ground relay. The cutout switch is then sealed. It should be operated only in an unusual emergency. Proper report made if the seal and broken. Otherwise, the diesel engine must be left offline. If the traction motor is cut en route with the engine left off the line due to the ground relay operation, the ground relay cutout with the millions of the manual ground relay cutout switch, the message must be sent. The superintendent inspection of the traction motor must be made with the first terminal when competent employees are available. Safety control operation. After the safety control operation occurs due to the emergency deadman locomotive overspeed when the emergency application of the brake occurred with any other cause in order to restore the power of the locomotive. The throttle lever that must be returned to the idle position. The deadman pedal to press the automatic brake valve handle placed in the lap position until the brake reduction is completed. After the brakes may be released in the normal manner. If unable to recover the safety control application of the brakes, and if the safety control application occur, the deadman pedal with the held down the speed below the maximum permitted. Safety features may be cut provided after the safety features are cut out with the engine is not alone with the operating end while the train is in motion. A report of the superintendent must be made without delay to the train. Leaving the locomotive. If necessary to leave the locomotive unattended as terminal weather conditions permitting, all diesel engines should be shut off, the battery switch is open, and lightning switch open, and the units have been lights not connected through the battery switch. The air brakes should be released and the hand brakes applied when necessary. The needles are should be chocked. Freezing weather precautions. During freezing weather, in order to prevent freezing of the locomotive water system on locomotives equipped with the steam generator, at least one of the steam generators should keep the surface together with the diesel engine from the same unit. The necessary valves are operated with the furnace steam for the water supply tanks on the locomotive. The other steam generated diesel engine with the locomotive that are not operating on. Locomotives equipped with the standby heater of the diesel engine is shut down. The standby heater should be operated. If the steam of the local plant is available, the connection can be made with the steam train line. But the locomotives are equipped with the necessary valve to operate with the locomotive. The steam used to prevent freezing of the locomotive water system. If the plant steam is used, it will not be necessary to operate the diesel engine stand by the heaters and steam generator on the locomotive. If the diesel engine are shut down with the steam that is not available, the standby heaters are not provided. All water must be drained from the locomotive. Are the indication of result abnormal condition various classes: high cooling, water temperature, lube oil pressure, high lube oil, section wheel, slipping ground, relay operation, dead engine, diesel engine, overspeed, locomotive overspeed, non-AC voltage, low oil, governor oil pressure, steam generator shut down, emergency brake application, radiator fan stop, traction motor blower stop, engine stop, excessive dynamic braking. Section 2, oil-fired steam generators.